All right, y'all. We are looking at the 1-11 notes. That's what's on the right side. I've also got the calculator open on the left side of the screen right here so that we can be able to use it for the notes today. Okay, so let's get rolling on this. Okay, this question is asking us to graph the parent function y equals absolute value of x. Okay, so what we're going to do is we're going to go into y equals over here. And what we're going to do to access the absolute value bars, those vertical absolute value bars, is we're going to do this right here. We're going to hit math, the right arrow, and then 1. Okay, math, right arrow, and that very first option right there, that ABS, that stands for absolute value. And we're going to graph the parent function, the absolute value of x. Comes up with this graph right here. Okay, this is a graph that we're very familiar with. This is a graph that we have already dealt with in the previous couple of lessons. So we're just going to write down a couple of observations about it. Okay, the first thing, what does the shape of the graph look like? Okay, we know this already. It's the shape of a V. Okay, gives that V shape. And we talked about in the previous lesson how that list of y values going down and then hitting the vertex and coming back up, that's where that comes from. Okay, on that note, this graph has a vertex point. That vertex point is right down here, the very corner of it. That would be the origin, 0, 0. There's your vertex right there. Now, this last part we have not talked about as much. We're going to talk about it a little bit in this lesson, but a lot more in the next lesson. Is asking the question, what is the slope of the left line segment? What is the slope of the right line segment? And if you will remember yesterday, when we graphed all of those points in the previous lesson, when we graphed all of the points that were on there, for every point to go from one to the next, we always went up 1 and over 1, up 1 and over 1, all up and down the whole line. On the other side, we're going down 1 and over 1, down 1 and over 1. So that means on the left side of our parent function, our original one, the slope was -1. And on the right side of our parent function, the slope was +1. Again, that is going to be more relevant in the next lesson, 1-12. Okay, right now, let's look at some variations on this. Okay, what we're going to do is we're going to go back to y equals, and we're going to leave y1 as it is right there, the absolute value of x. In y2, we're going to re-enter this function. We're going to enter y equals absolute value of x. So we go math, right arrow 1. We have the absolute value of x. We go outside and do +4. Okay, so on this next graph, we're going to have the original one, and we're going to have this other one with a +4 attached to it. Now look at what happens. We have our original, and there's our new one with the +4. Okay, what happened? The question on here is, how does this new graph compare to the parent graph? Okay, the original function, what happened on this red one compared to the blue one? And the answer, you can tell, is that the whole thing has been shifted up by 4 units. The whole thing shifted upward by 4 units. Okay, and we can see that everything is in the same place. This vertex didn't move left or right, it just went straight up right there. Okay, so now let's look at this next one. This next one on y2, instead of having absolute value of x +4, we're going to replace that +4 with -7. Okay, so our previous one went up by 4 when it was a +4. This time we've got a -7. So take a guess at what's going to happen, and then watch what actually does happen. First, we have our original parent function right there. Then our new one with the -7. And look at that. Just like we were expecting, the whole thing was shifted down by 7 units. Okay, so what I'm learning from these two questions right here is that if you have a +4 on the outside, if you have plus something on the outside, it moves up. If you have minus something on the outside, it moves down. Okay? So anything that's added or subtracted on the outside affects how much the graph is going to move up or down compared to the original. Now, let's do number 4. This is asking us about absolute value of x +5. This time, the +5 is inside the absolute value bars. So you remember your math, right arrow 1, and we're going to go x +5 right there on the inside. Now let's see what happens here. we hit the graph, we have our original with the vertex at 0, 0, and look at our new one. That is an interesting discovery right there because we've not moved up or down any. This time the number was on the inside of the absolute value bars and it moved us left and right instead. Okay, look at this. It moved us with a +5. That's another interesting thing all by itself. With +5, it didn't move us to the right, it moved us to the left. Okay, that whole graph has been moved to the left by 5 units. Go to your next one. On the previous problem, we had x plus 5, and it moved us to the left. This time, on the inside, we're doing x minus 3. Look at what happens compared to the original. This time, instead of moving to the left, it moves us to the right. We went to the right by 3 units. Okay, that's pretty interesting all by itself, too. Okay. For right now, we're going to skip number 6. We're going to talk more about that in the next lesson. I want to skip on down to number 7. Okay, this time there isn't anything added or subtracted. Oops. There isn't anything added or subtracted. Instead of anything added or subtracted, we just have a negative sign out in front of it. So we're going to hit the negative and then our absolute value bars. Okay, and look at what happens to this one. We have the original. That looks like that. And the new one. Okay, so this one is the biggest change out of all of them, okay? You can see that the vertex didn't move, right? There was nothing added or subtracted, so the vertex stayed in the same place, but that negative sign made the whole thing flip over upside down. What happens is it reflected over the x-axis. It flipped the whole thing upside down, okay? So, based on all of this, let's do a quick summary of all of the things that we've talked about so far. Okay? We're looking at this example function up here. Okay? And if there's nothing else that you're getting out of these notes, this information down here at the bottom, this is the important stuff. Okay? Using this example function right up here. Okay? If you're adding k, and we can see that k is this little thing located right there. Okay, if you are adding k and subtracting k, that's something that's on the outside, something outside of the absolute value bars. If you're adding it, it shifts the whole graph up. And if you're subtracting that number on the outside, it shifts the whole thing down. Now let's talk about h. H is this thing that's on the inside right there. Okay, this time if you're adding h, it shifts just like on this problem up here. If you're adding a number on the inside, it shifts to the left. And if you're subtracting a number on the inside, it shifts to the right. Okay, now that's very confusing all by itself because usually when you're adding things, you're talking about going to the positive x values to the right. Well, that is not the case right here, okay? This time on both of them, adding goes to the left, subtracting goes to the right. They're both the opposite of what you would normally expect, okay? The way we remember this, the way we keep track of this fact right here is we say that insiders lie. Insiders lie. Okay? If it's inside the absolute value bars, you go the opposite direction of what that little sign says. All right? Now, those two numbers, h and k, those numbers that you're adding and subtracting, those are what give you the vertex. Okay? Those two numbers, h and k, are what give you the vertex. So however much you've shifted up or down, left and right, you can tell how much you've shifted up or down, left or right by where the vertex is located. All right? And our last one, if there is one of these things, I'm going to draw a little arrow and make sure everybody can tell that is a negative sign. If there is a negative sign in front of the absolute value, the whole thing is going to reflect across the x-axis. And that word for reflect, of course, you'll remember from algebra or from geometry. The word reflect means flip. Okay, the whole thing is flipped over the x-axis, just like this last example that we did right here. All right, so that is all of the notes that we have for today. We're going to call it right there. Tomorrow is going to be closely related to this. We're going to look at what happens if you have a coefficient, something multiplied out in front of this right here. All right, that's all we've got. Y'all have a good day.